Hi, so I'm Sophie Dominguez, and my group will be doing question 5 for the quarter 4 group assessment, and I have the longest hair in my group, so I'll be starting with 5A. Here's our question right here. So it says the graphs of the polar curves r equals 4 and r equals 3 plus 2 cosine theta are shown in the figure above, so right here. The curves intersect at theta equals pi over 3 and theta equals 5 pi over 3. And then A says, let R be the shaded region that is inside the graph of r equals 4 and also outside the graph of r equals 3 plus 2 cosine theta, as shown in the figure above. Write an expression involving an integral for the area of R. Okay, so we are going to use the formula. So area equals okay, so we're going to use this. So area equals 1/2 times the integral from beta to alpha of r squared d theta. So because it's given in our problem that r equals 4 and r equals 3 plus 2 cosine theta. So because we want to write an expression involving the integral for the area of R. So R is the shaded region right here. So because we are trying to find the shaded region, we are going to subtract the two values of R in our area expression, but you'll see when I do that in a second. So we're going to do area equals, area of R. Be a little more specific. So area of R equals 1/2 times the integral of 5 pi over 3 to pi over 3. And then this is where I'm going to subtract the two R values. So we have to square R. So 4 squared minus 3 plus 2 cosine theta squared d theta. And because all they want us to find is an expression involving the integral for the area of R, this would be our answer. So just to kind of wrap everything up, our answer, the area of R equals 1/2 times the integral from 5 pi over 3 to pi over 3 of 4 squared minus 3 plus 2 cosine theta squared d theta. So for 5B, the question here says, find the slope of the line tangent to the graph of r equals 3 plus 2 cosine theta at theta equals pi over 2. Okay, so I'm just going to write down some information so I don't have to keep looking back at the question. So r equals 3 plus 2 cosine theta at theta equals pi over 2. Okay, so I'll just kind of bubble this off. So because we need to find the slope, let's write this down. Slope equals dy over dx, which equals dy over d theta all over dx over d theta. Okay, and then y equals r sine theta and x equals r cosine theta. So these are kind of the standard, what we're going to refer back to as we complete this problem. So I'm just gonna bubble this off too, just to kind of, because there's gonna be a lot of written work. Okay, so let's start with y. So y equals r times sine of theta, which equals 3 plus 2 cosine theta times sine theta. Okay, so using the product rule, we want to find dy d theta, which will equal -2 sine theta times sine theta plus 3 plus 2 cosine theta times cosine theta. Okay, so yeah, just take a second. So next we are going to, because we have to find it at theta equals pi over 2, we're going to put that in. So dy over d theta at pi over 2. Okay, so this will equal -2 plus 3 times 0, which will equal -2. Okay, cool. So we found dy d theta at pi over 2. So I'm going to break this off again. And now we want to go for x. So x equals r cosine theta. And then this will equal 3 plus 2 cosine theta times cosine theta once we plug that in. And then using the product rule, we want to find oops, I just wrote my paper. Can you still see? Okay. dx d theta, which will equal -2 sine theta times cosine theta minus 3 plus 2 cosine theta sine theta. Okay. So just like we did with y, I want to find dx d theta at pi over 2. So this will equal 0 minus 3 times 1, which equals -3. Okay, so now we have our two values. We have -2 and -3. So back to here, we have, referring back to what I wrote in, oops, you can't even see it, sorry. Referring back to what I wrote in the beginning, we have slope equals dy over dx, which equals dy d theta all over dx d theta. So now we want to put these values on top of each other. So we have -2 over -3, which equals 2 over 3. Because this is a free response, we kind of want to restate the question to wrap it up. So I'm going to say the slope of the line tangent to the graph of r equals 3 plus 2 cosine theta at theta equals pi over 2 is 2/3. Okay, so the slope of the line tangent to the graph of r equals 3 plus 2 cosine theta at theta equals pi over 2 is 2/3. I'll box that. Cool.
Hello, my name is Raymond, and I'm going to be doing question number 5, part C of the 2018 AP Calculus BC free response questions. For this question, a particle moves along the position of the curve r equals 3 plus 2 cosine theta for 0 is less than theta less than pi over 2. The particle moves in such a way that the distance between the particle and the origin increases at a constant rate of 3 units per second. So that is going to be the distance between the particle and the origin, r, at a constant rate of 3 units per second, so dt. And that is going to equal +3. Now find the rate at which the angle theta changes with respect to time at the instant when the position of the particle corresponds to theta equals pi over 3. So we want to find d theta over dt. We want to find the rate at which the angle theta changes with respect to time. Not equals, sorry. We want to find d theta over dt at theta equals pi over 3. This is what we need to find. So to find this, we're going to have to take the derivative of the given equation, r equals 3 plus 2 cosine theta. And that is going to be d theta, or no, not d theta. It is going to be dr d theta, because we take the derivative of the equation with respect to theta. So doing that, we get negative 2 sine theta. Now to find d theta dt, we're going to have to use basic algebra with these two derivatives. So we're going to do dr dt times the reciprocal of dr d theta, which is going to be d theta dr. The dr cancel out, and then we're left with d theta dt. Sorry, let me fix the d theta dt. So plugging in the equations here, we're going to get 3 times the reciprocal, negative 2 sine theta, and we're going to get negative 3 over 2 sine theta. And that is our d theta dt. Now we plug in theta equals pi over 3. We find d theta dt at theta equals pi over 3. So plugging this in, let me just rewrite it over here, equals negative 3, 2 sine of pi over 3 equals negative 3 over 2 times sine of pi over 3 is square root of 3 over 2. The 2's cancel out, and this becomes negative 3 over square root of 3. And now we're going to rationalize the denominator by multiplying the numerator and denominator by the square root. Square root of 3 times square root of 3 is just 3, and negative 3 times square root of 3 is going to be negative 3 times square root of 3. So it's going to equal negative 3 square root of 3 divided by 3. These 3's here cancel out, and this becomes negative root 3. And while we indicate the units of measure, the angle theta with respect to time decreases at a rate of negative root 3 radians per second. And this is our answer.
Okay, for question 1B on the 2018 AP Calculus BC free response question, it asks, during the time interval of 0 to 300 of t, there are always people in line for the escalator. How many people are in line at time t equals 300? So first, we should recognize all the information that is given. It says there are 20 people in line at time t equals 0. And if that's 20 people in line at time t equals 0, that's the base amount of people that there will always be. And then we're going to solve for p of t. Let's put p of t, because then as for people in the line at any given time. So there's 20 people in line. And there's the amount of people that are entering the line is r of t. So let's add r of t, and then we have to subtract it by the constant rate of people that are leaving the line, which is 0.7 per second. And then we have to find that this amount as an integral from time intervals of 0 to 300, because we're trying to find how many people there are in line at time t equals 300. So therefore we have to find how many people came and left by the time because 300. So we wrote it here. Let's expand R of t to the equation that or formula that they give us. 44 t 100. Okay, and we're just writing the formula that they give us, so this isn't any like math being done so far. So then we're gonna have to find this, and it's gonna be the people that are coming onto the escalator, and then it's just gonna be the people leaving. Then we're going to find that as an integral from time interval from 0 to 300 to find how many people there are on the people in the escalator at time 300, and we're gonna add that to 20 because that's the base amount of people there will always be. Since at time equals 0, there's gonna be 20 people always. So the calculator here, because we don't really want to solve that, we can use it on the calculator. So where is it? Sorry, nope, not second. Math. Oops. Sorry. Okay, let's we go to the math mode and then get the interval on the calculator, and then we go to 300 and 0 for, oops, 0, and then we plug in the formula that we were given, and you can use any variable really. I'm just gonna use a because it's the closest one right here, and I could access it the easiest out of all the other variables. And just plugging in the formula that they give us in the problem. And oh, oops, forgot we should add another parentheses. Oops, right here, 44, because we're going to be subtracting 0.7 as well, so we're going to need another parentheses. My apologies. To the third power, and then 1 minus a divided by 300 to the 7th power. Oops. To the 7th power, and then parentheses there, and subtract that by 0.7, and then put d of a, since a is the variable we used, and then we get 60. So the amount of people that are the total amount of people that are increased into the line by the time it gets to 300 is 60 people, even accounting for the amount of people that left. And then we add that to 20, the base amount of people that there will always be in the line, and then we get 80 people. And that means that at time t equals 300, the amount of people will be